Hello and welcome to this week's problems. Let's get started with Seb and his apples and his pears. So we bought 2 apples and 2 pears and spent £1.59 altogether. And we know how much apples cost, but we need to know how much 1 pear costs. So to help us do that, we're going to break it down. We've got 2 apples. So I'm going to draw a box for my apples. So I've got my apple here, got another apple here, then I've got my 1, my 2, my 3 pears. Now, I haven't got a lot of room to write in, but I'm going to try and put 24p in each there. So that is 24p, that is 24 pence, and I don't know how much those 3 pears cost. But what I can do is I can put those two 24s together, that will give me 48. And because I know how much the whole set cost, which cost 159p or £1.59, 48p here, then I can work out how much the pears cost me altogether. Once I've worked out how much the pears cost me altogether, I can divide that number by 3. That'll tell me how much 1 pear costs. And now we can move on to the next problem. We've got Freddie is half as tall as his mother. Freddie is 1 metre shorter than his father, and Freddie's father is 180 centimetres tall. How many centimetres tall is Freddie's mother? Now at first glance it seems rather confusing, but if we break it down into sections and use the bar model, it should be fairly easy. So we've got Freddie is half as tall as his mother. So here's Freddie's mother. There she is. We'll put an M in there. We know Freddie is half as tall, so I'm going to put a little F in there for Freddie. So that's the first part. So we've ticked off that first bit of information. Freddie is 1 metre shorter than his father. So I'm going to draw another bar. Got Freddie's father, there he is. Okay, I'm going to put a D for Dad, since I've already used an F for Freddie. Now we know he's 180 centimetres tall, is Freddie's dad. And Freddie is 1 metre shorter. So we've got 1 metre here, and then this bit here is Freddie. So if Freddie's 1 metre shorter than 180 centimetres, then Freddie must be 80 centimetres tall. Not come out very clearly. So if Freddie is 80 centimetres tall, then we can then put that 80 into this box here where we'd put Freddie before. So I might draw another one in fact down here. So I've got Freddie's mum. Remember Freddie was half as tall, so if we've got 80 here, we'll have another 80 there, and then we can work out then how tall Freddie's mum is. Now this next one, again it seems a little bit confusing when you first look at it, but when you break it down it shouldn't be too tricky. It says J and K stand for 2 numbers, double J is half of K. I'm going to try and work out what that means. So if I've got J doubled, so double J, so that's 2 J's, that is half of K. So I've got my J's here at the bottom. 2 of them is half of K, so K's on the top and my J's down here. And it says write numbers to complete the sentence below. So when J is something, then K is something else. So we think about what J could be. So when J is 5, then K must be what? So these two are 5, remember that's half, so we'd have a 5 here and a 5 here as well. So I could just say when J is 5, then K is 20. That's one way of doing it. I'm sure there are plenty more ways of doing it. So if you could find a different way to that, that would be fantastic. So next one we're going to do, in fact there's only 2 left. In a class, 18 of the children are girls, a quarter of them are boys. So straight away we're thinking in quarters, because that's the fraction that we've got in our problem. So I'm going to divide my bar up into quarters. So that's 4 pieces. So we've got our class at the top, and we've got our quarters underneath. So now we know that, we can start thinking more about the problem. So 18 of the children are girls, a quarter of them are boys. So this section here, these are the boys, which means that this group here must be the girls. And we know there's 18 of them. Okay? So if there's 18 of them, but there's 3 equal sections, I divide 18 by 3, that should give me 6. And because we know that we have got all the sections equal, that tells me there's also 6 boys. And once I've worked out the 6 boys, and there's 18 girls, it shouldn't take me too long to work out how many there are in the whole class. I'll leave that little bit up to you. Last one then, write these in order of size, starting with the smallest. Now, we can see we've got a fraction first, then we've got a decimal, then we've got another decimal, then we've got a percentage. So the way we do this, putting them in order, is try and turn them all into the same thing. Now, 3/4, we should probably know, is the same as 75%. That's one of those facts that I think we should just know. So I'm going to convert that into 75%. Now I also know percentage means out of 100, and here we've got 0.34. If we think of it like money, that would be £0.34, and we know pence is out of 100, so this makes 34%. Now here, you might think if you weren't paying attention that was 7%, but if we look carefully we realise hopefully that that's just a 1-digit decimal. If we put that 0 on the end, it becomes 0.70. Now it looks more like pence. We can think of that as 70%, and this is already as a percentage. So then we can write our numbers out in order of size. Now it's very important when we do this that we start with the smallest over here and the largest over here, and also that we write the original amount rather than our converted amount. So once you've worked out which order the percentages go in, write the original amount. The original, whether it's a fraction or whether it's a decimal, underneath.
Does it be the same? Well, if it wouldn't need to, it would just say Alex swam 111 lengths then, wouldn't it? And Francis swam 111 lengths, and they're both the same.